Unpeeled. So at the moment, we're going to be looking at a couple of news stories today. The first is that Christian Gora is using a WASP 3D printer and loam to 3D print chicken coops and outbuildings and all sorts of small buildings in a rural setting. First off, he's using loam. Loam is kind of a soil with sand, silt, clay kind of material. Now, first, little kind of a negative thing about this that the sand, silt, and clay thing to me is not a great material because we need soil and we really would would really need it. So I'm not sure if that's a great build material. Now, the reason why it is a really nice build material is the idea is it's a really local material. It uses sand, silt, and clay found locally mixed with hay. And he's able to get that to extrude on his WASP 3D printer to make kind of small local buildings. Now, these buildings, because they use local materials, use a lot less energy, a lot less transport energy. There's a lot less CO2 in these materials than if you would, get a concrete, have to make the concrete and ship it halfway across the country. So that I like. Now, the other thing that I think is really charming about this is that he's using small local rural buildings. So he's saying, look, there's a market out here for buildings that are at your farm or at your industrial farm or at your house in the country. And that to me is a potentially very lucrative, very interesting market because, well, those are the kind of people that will care about, about the environment and about locally sourced materials and would maybe look at that. So I think the world is more than just buildings and houses and tract housing and things like that. I think these kind of things could also have a 3D printing construction outlook and a path to market for materials that are just not concrete, but are just much more sustainable. So now we've got a new news. That's Mycorrhiza and Revo are making a mycoprotein. Mycoprotein is a kind of like fancy way of saying a fungi-derived protein. Now, these fungi-derived proteins can be found in all sorts of things like, think about a vegetarian schnitzel or vegan, like kind of little roll or something you would buy. They put them in there as a food additive and they add a lot of protein. And also, if you know this, if you cook down mushrooms like really slowly for a long amount of time, it's really very kind of meaty flavor, very full flavor, and that kind of flavor, they're now using that, for minces and kind of like to make vegan foods kind of a little bit more meaty. But this material called ProMyc or Pro MYC has now been used with a different processing method, which makes it usable in Revo's 3D printers. So that means that this material can be shaped not only into kind of like a schnitzel kind of thing, but also into maybe more cut of meat kind of thing, a more high value object where the 3D printing can add a lot of texture and mouthfeel and kind of like a better definition to this meat. Revo itself is kind of the fish 3D printing people. They've worked with on salmon spread and smoked salmon and these kind of things. They may use this partnership to expand into meat, but they're looking right now at using this in a kind of fish kind of way. So I think this kind of partnership and partnering is going to be more important as we go forward because there are considerable costs and considerable R&D expenses in this 3D printed foods. So this is a great example, I think, of something that's going to happen a lot more often going forward. The next is the Formnext Startup Awards. So the Formnext Startup winners they do that each year. And just like a lot of awards, it's good. I really like, in particular, the Formnext Startup winners because they are some interesting startups. There's always some interesting startups that I've heard of, and some interesting startups that I haven't heard of yet that I would find to be worthwhile. So in this case, what we have is the company is called Alpha Powder is one of them. Now, Alpha Powder is a company that is doing the pulverization, spheroidization of and essentially compounding of polymer powder for powder bed fusion. It's very difficult to make these powders right now. It's also very difficult to develop them because you have to use a lot of material every single time. You have to cryo grind these materials as well, which is a very energy intensive process, which not a lot of people are a master. So you have to go to Dressler, for example, to do this. It's a company specialized in this kind of thing. ALM uses this process to create custom powder. So you can go to ALM and make a powder in a particular color or grade or whatever you want. Apart from that, there's very few people actually making their own powders, apart from like companies like Evonik and Arkema and stuff. So, to democratize this, Alpha Powders are putting up a machine that makes it easier and cheaper for you to make your powder and also to test and iterate these powders. So I think this is like a really, it's kind of a maturity thing that we can afford to support a company like this, that a company can come up with this innovation. This could really make a big difference. I think also it'd be interesting to see if we could use recycled materials in these powders for a limited amount of time to see if we can make really high value objects from recycling. Not only have to downcycle stuff, but really make a powder that would work. You'd have to mix in some virgin material, would work with some recycled material to create a really high valued object using 3D printing. I think that'd be really exciting as well. Another company is Photosynthetic, which is they have like a 3D lithography technology analogous to, let's say, direct light lithography or two photon or one photon lithography that's similar to these type of technologies. Now, what the company is trying to do is kind of, I'm not saying it's the holy grail of the micro nano printing thing, but it's a really important thing. Because on the one hand, a lot of these companies, you can make it small if you want, right? Or you can have really small feature sizes, or you can build something quickly. And it's kind of a give or take thing. And what they say they can do is have a feature size of less than a micron, but they have print speeds up to 6 millimeters per cubic millimeters per second. So that could mean that you could, in a lab environment, for example, print useful objects quite quickly with really, really small features. And I think there's a real market for that in a lab setting to really build metamaterials, to really build things with really advanced functionalities. Another company, we talked about them before, is Rivelin Systems, or another winner. Rivelin Robotics makes a robot arm that scan your object, and then the robot arm will finish your object. So it'll mill it down or tap it or finish it. Another company is SphereCube. SphereCube is it's one of these things where you're like, why did nobody think about it? And then it's, well, probably because it's super complicated. It's like kind of a laser curing for reinforced polymer, laser curing kind of thermosetting matrix, carbon fiber reinforced thermosetting matrix process. So it uses lasers to selectively cure essentially these materials. And it could make a continuous carbon fiber process with a high yield that's very automatic compared to like the hand layup systems and other ways that people use now with the autoclave and all this stuff. Now, this is, of course, all impossible objects, or Revo. Many companies are working on this, but it's nice to see a new startup trying to tackle this really complicated problem, making really high-grade composites materials without manual labor. Another company is Lattice Medical. Lattice Medical, along with Bellasano, and there's a couple of other companies working the same thing, are looking at kind of breast reconstruction, but then using reabsorbable polymers. This is a startup that came out of CHU Lille, France. And they have a patient-specific bioprosthesis, and this is bioabsorbable in the body. So what it can do for example, a mastectomy sufferer. So there's a lot of people that have breast cancer, a lot of women have breast cancer. A lot of these end up doing a mastectomy where the breast is removed. This has a lot of self-image issues. It's, of course, a horrible thing to have happen. And there's very limited things that we can do to ameliorate this. And one thing was, like, for example, to use kind of the same procedures that they use for breast augmentation. And that would involve you having to have a saline sack of material that you carry with it. But what these guys at Lattice Medical and Bellasano want to do is to have a patient-specific. So before you undergo the mastectomy, they can do a scan of your breast. Then they can do a patient-specific implant that kind of augments your breast, or in a sense reconstructs it. And in that reconstruction, we'd hope, of course, that breast more resembles the one you used to have, and that you'd be more happy with it and more happy with yourself and your body as a result. Now, of course, on top of this, for Lattice Medical, even though they say the focus is on these breast reconstructions, on top of this, it's easy to see, for example, how this could have a really big role to play in breast augmentation as well. So the opportunities for this company in Bellasano, the other one, are considerable as well. So my name is Joris Peels. This is another version of 3D Printing News Unpeeled. Thank you so much.